Okay, this is homework help for your volume with shells worksheet. I'm going to go through 3, 4, 5, 8 in case you wanted to skip ahead to just one of them, you could do so. But starting with number 3, and I might be perhaps skipping, I think this one you can graph. You got the line, you got the quadratic, and you're going to rotate this around the x-axis. Now, whenever you're doing shells, shells are parallel. So that means that your reference angle, or your reference, not angle, your reference rectangle here needs to be parallel to the axis you're rotating. Okay, so that means that we are doing this with respect to y. Okay, so for shells, if it's around the x-axis, it's in terms of y. If it's around the y-axis, it's in terms of x. So that is something that's very different between shells versus both discs and washers. Okay, so, this shell, let me rotate this around. This shell looks something like this. And the volume would be, you can always bring that 2 pi out front. And then since we're doing this in terms of y, look at your bounded area. It goes from y equals 0 to y equals 4. Okay, it's 2 pi RH, that's the surface area of the cylinder, minus the 2 circles on the top and bottom. So 2 pi RH. The radius of this cylinder is x. Sorry, no, his y. We're doing this in terms of y. The radius would be y. And then the height would be it would be a difference, right? So the height would be, since it's in terms of y, it's going to be right function minus left function. Okay, and then here's where we run into a little bit of a problem, because my right function I know is y equals x squared minus 2x plus 1, but I need that to be in terms of y. Okay, so we are very lucky that this factors so nicely. Oops. This is y equals, this is a perfect square, x minus 1 squared. Okay, so then that means that we can square root both sides, and it is technically plus or minus. I'll go ahead and add 1. However, we only need the positive version because that's the side, it's the right side that is bounding the area. So it's going to be right function, which is the positive square root of y plus 1 minus the left function. Oh, I need to solve for that one too. That one's not so bad. You'd get 1 plus y over 2, and that would need to be in parentheses. That's just solving the line here to be in terms of y. And then, so 2 pi r h, and then times the thickness, which is dy. You plug that into your calculator, and I think I got 13.4. That's what you should be getting. Okay. Okay, so then this one, also around the x-axis. If it's a shell and it's around the x-axis, we're doing in terms of y. Okay, so then these shells would look like this. There's one shell. Okay, so volume would be, oh, and so when it comes to graphing this, you have to first graph y, the square root of y minus 3 to graph that. Volume would be 2 pi If it's around the x-axis and we're doing it in terms of y, you're going to go from 0 to 2, it looks like. Those are y values. And then the radius is always the variable you're doing this with respect to. So it's always going to be 2 pi and then x or y, depending on which variable you're doing it with respect to. So always y, that's the radius, and then times the height. The height is again this y minus, or right minus left idea. So y squared plus 3 is on the right, minus x equals 2 is on the left, dy. You plug that into your calculator. Okay, so now switching to the y-axis. Okay, so for shells, if we're rotating around the y-axis, we're going to do these in terms of x. Again, just another thing to keep straight between shells versus discs. And the most important thing to keep straight between shells versus discs and washers. Okay, shells are parallel, so we're going around the y-axis. I'm going to draw my little reference rectangle here so that it is parallel to the y-axis, and then my shell would look something like that. Okay, so volume would be 2 pi. And then x values now. So we're doing this in terms of x. You know, writing these little notes right here for yourself are a good idea probably. So in terms of x, I'm going to go from 0 to 1, it looks like. So 2 pi, r in this case is x, just like in the last two examples, it was y both times. Okay, so the variable you're doing this with respect to is always the radius. So your radius, and then this time, instead of right minus left, it's going to be top minus bottom. So it's going to be x squared plus 3 minus bottom, which is y equals 2. And then this time times the thickness of that shell, dx. And you would plug that into your calculator. Okay, this one, y equals 5, y equals 2 over x, and x equals 2. And again, around the y-axis, so we're going to rotate this. Oh, goodness, let me try that again. I miss pencil and paper, guys, so much. I miss my document camera. I miss you guys. I miss all the funny things you say. Okay, so volume. Oh, y-axis, and we're doing shells, so that means in terms of x. So we've got 2 pi. And then this goes from this, in whatever the x value is there. And actually, I don't know what that is, so I need to actually solve for that. So that's when 2 over x is equal to the line 5. Okay, so remember these just switch places, so that means x equals 2/5. So we're going from 2/5 to the other x value is clear, 2. Okay, radius is x, 2 pi, r, h. The height in this case is top minus bottom in terms of x. So top is 5 minus bottom is 2 over x, and then times the thickness, dx. And you plug that into your calculator. So you're working on this worksheet over the weekend. And then on Monday, I'm going to try doing a Zoom meeting with you guys, and we can talk about volume a little bit more. And then I might as well mention Tuesday and Wednesday are both going to be quiz days. Tuesday is going to be like 5 to 10 questions, just shells. And then Wednesday is going to be a quiz, 5 to 10 questions with all different types of volume. Now, I have to specify which axis you're rotating it around, and then I could specify whether I want you to do the shell method versus the disc/washer method, but that's something you could determine if I didn't specify. You'll just have to read the directions closely.